That's the course code and the course name, CIT315 operating system. And I think it's a course that both CS and IT are doing because both of us, we deal with operating system while we're operating the computer. So today, we'll start with Unit 1, processes and states. Our focus in this course is, to check everything that the operating system is all about, how it operates, what it is, what it does, and some other things about the operating system, and the content and the things that make up the body called operating system. Of course, we know that we can find the operating system in our computers. So, please, I hope you guys can hear me. Yes, so that we're not talking
Can
to.
hear you.
All right, thank you.
Me, I
So,
can
processes
hear you.
and states, that is what we are concerned about today. We are going to talk about what is a process. We'll talk about process control block. We'll talk about state process model and state diagrams. A two-state, a five-state. Then scheduling algorithm, that is if we still have time, and then cases and examples. Before now, you've just been hearing operating system. You might not know that there are quite a lot of things involved in the operating system. Now, as a form of introduction, all multi-programming operating systems, from single-user systems such as the Windows that you use in your house, on your laptop, on your desktop, to mainframe systems such as IBM's mainframe operating system, which can support thousands of users, are built around the concept of the process. So what we're trying to say here is that whether you are talking of a single user computer, like the type of your house that uses Windows, like your laptop that uses Windows or maybe Linux and the rest of them, and then to the large one like IBM mainframe that supports so many users to use it simultaneously at the same time. All of them, they follow a principle called the process. So what is this process? That's what we want to look at in this lesson. In general, the operating system must switch between the execution of multiple processes. The way we are working now, let me give an example. I open this material now on my system. Is a process ongoing. This material that you are seeing now on the screen is one process ongoing. This meeting that we are doing now is another process ongoing. I have some other things I've opened on the system before. They are all processes ongoing. So for the operating system to be switching, like now if I minimize this material now and go to something else, the operating system will need to switch between processes. One process is the one that open the PDF. Another process is the one operating the video call that we are on to now. Another process is the one sharing my screen. So switching between processes. For the operating system to do that, to maximize processor utilization while providing reasonable response time. What they're saying is that this process we are talking about, just imagine that I open three, four applications and I'm working on them simultaneously. Each of them represent a process going on my operating system. If there is no operating system to manage those processes, it means all the processes will just pop up at the same time on your screen. Your screen will just be scattered and then no manager, nothing to manage it. And also, it will cause the system to be very slow. If you remember those times when they just started some desktop like this, that they used to be slow. Either when the RAM was very small, then that if you open two processes together, the system will be lagging. Now we want to talk about processes here. Processes you will see better when we get to the definition. This is just introduction to give you a picture of what we are going to talk about. Now, the operating system must allocate resources to processes in conformance with a specific policy, e.g., certain functions that are of higher priority, while at the same time avoiding deadlock. The operating system may be required to support inter-process communication and user creation of processes, both of which may aid in the structuring of applications. This is a very clear thing. I don't think it's something we should dwell much on. The picture is clear, it's an introduction. By the end of this class, we should be able to do some things that will show that you have attended the class. One, explain what process is. That's the first thing. You must know the meaning of process before you leave this class. If that is the only thing you leave the class with, you are done. Identify the states of process. Then we should be able to identify the importance of context switching, and then know how to interrupt a running process. How to interrupt a running process. So let's start there. So I will start using our method now. I'll call on someone to read this main content. What is a process? You are not just reading it, you are the one to teach us. Once you finish teaching us, I'm not saying anything on it. We'll just move on to the next. So you must take your time, read it very well to us, and explain to your understanding. If you like, you can ask us questions. You are the teacher now. So who will do that for us? Let me see. Let me start. Boss lady, are you around? I'm giving you boss lady or Reese.
Yes,
Which of you is available? Reese or boss lady? Anyone? I want to start from the bottom. Reese, so are you there? Take us this. If your place is noisy or you are still at work, just indicate. We'll give it to another person.
okay, maybe I should read back.
Yes.
So they say, what is a process? A process, a program in execution. That is, in execution, the process is a program that has been programmed here. So a process is more than the program code. This is sometimes known as the text section. So it also includes the current activity. So the current activity, what we are doing now, is also a process. So as represented by the value of the program counter and the content of the uh, processor's register. So the process generally also includes the process stack, so which contains temporary data such as functions, parameters, return addresses, and local variables, and data section. It contains global variables and a heap, which is memory that is dynamically allocated during process in runtime. The program is a passive entity that does not perform any action by itself. It has to be executed if the action calls for to take it. A process is an execution of a program. It actually performs the actions specified in a program. An operating system shares the CPU resources among processes. This is how it gets users programs to execute. So the list how the process is being executed. So the first one is the start. So and the second one is the heap, the data, and the stack at the end. So I should explain that one before we go further.
Yes, yes.
So it said the process um, so a process is a program in execution. That is, it's an active entity unlike a program, which is a passive. The main component of a process include program code, text sector, contain executable instruction, program counter, point to the next instruction to be executed. So CPU register, load temporary data, and start store function parameters, return addresses and cookies variables. In the data section, so contain global variables, stores dynamically executed memory during runtime. So they ask us the difference between program and process. So passive entity and active entity. Passive
Okay, your place is somehow noisy, so let me take it from there. So please, you
okay, take it from
need to mute yourself. Thank you. So,
medicine.
uh,
No, stop. Yeah.
what we are saying now is, okay, please, it's okay, sir. Thank you, sir.
Okay, we no get way pass for this one. Okay, let me mute myself.
Okay, thank you. So, he has done justice to that, but let's take it a bit more explanatory so that we try to digest it. You already know that from the introduction, we have tried to create the picture of a process. As you open a program on your system, it becomes a process. Just from the meaning, from the direct meaning of process, you understand. So, but there are some things I want to point our attention to here. All these ones that were boldened, stack, because I know that most of us don't know the meaning of a stack now and would not ask. Although there is a general meaning here, like this one, they said the process generally also includes the process stack. And what is a stack? Which contains temporary data such as function parameters, return addresses, and local variables, and a data section, which contains global variables, and a heap. And what does the heap do or contains? A heap is memory that, or is a memory that is dynamically allocated during the process time. Mm, so what this is trying to say is the way we open a program that is running on the system and we have it as a process. mm, Normally, the data section, its work is to store. No, if you are not a programmer, you don't understand global and static variables that they mentioned here, which is the work of the data section. The data section, which stores global variables, is it static and global is a word they use at the back end or doing your programming. You understand it if you are a programmer. Now, what does it do? What is the characteristics of the data section? It's to what? It does memory is allocated at compile time. So it allocates memory to the process that is ongoing at a compile time. It also exists for the entire lifetime of the process. So data section is in motion as long as that process that you open that is ongoing is still on, as long as the process has not ended. One thing you should know about process is that it has the start. When you start a process, it starts, that is the beginning. The operation is ongoing. You can also terminate it. It can end. So you have the beginning of a process and the end. That is why when we started this meeting now, it started and we continue, it's continuing in motion. At the end of the meeting, we'll end the meeting, that process has ended. But during the course of the meeting, this meeting we are doing now has been eating a lot of resources on my own laptop. Likewise on those of you viewing it too. So many things are being lost, memory are being used, utilized, and the rest of them. But it's not just about the process ongoing. There are so many things ongoing under that makes that process a success or a possibility. Those are the things we are trying to break into pieces. Mm, and then for the data section, we have the initialized data and then the uninitialized data, which is, okay, let's not talk too deep on that one so that I don't confuse you guys. So what of the heap? That is for dynamic memory allocation during process, which means assuming this heap, the meaning of dynamic allocation is that you know that as I'm recording this our class now, when we started and we are just 5 minutes, excuse me, we were just 5 minutes into the class. The memory I have exhausted, and now that we're about 10 minutes into the class, will be less than the one we have used so far. So as the meeting is ongoing, it's consuming more memory. That is dynamism. The heap is responsible for the continuous usage of memory. So it will be so as the heap is noticing that okay, this meeting is going on, 1 more minute, it allocates more memory. Okay, it's still continuing, allocate more memory. So that is the work of the heap, dynamic allocation of memory. You should note that, and then the heap grows upward. That the work the heap does is that it grows upward. The more the runtime of the process, the more memory the heap, consumes. And then the heap can be controlled by the programmer. Can be controlled by the programmer. Now let's talk about the stack, which is the last thing there before we move on to another thing here. The diagram will be explained and we can move on. Now the stack stores function called information for a process. So the work of the stack is to store functions like local variables, function parameters, and then return addresses, and then your CPU, saved CPU registers. That is work of the stack. And what the stack normally do is that it allows automatic allocation of memory. On its own part, it grows downward in memory. The heap grows upward in memory. The more the meeting is extending, the more memory the heap consumes. While the stack grows downward in memory. So each function, for instance, now, when we started the meeting, we did not initiate recording. By the time we initiate recording, the stack already knows that the maximum memory I have uh, on my system, let's say, is 40 gig that is left. Anything I'm going to do, you understand, cannot be more than 40 gig. So as we commenced the meeting the other time, what the stack is doing is reducing my system memory small small, that okay, this thing you are doing has already taken 4 gig, remain 36 gig. You understand? That is what the stack is doing. But the heap, what the heap is doing is, that one is saying that okay, ah, uh, you have 36 gig. Oh. Now, sorry, you have 40 gig. This meeting is going on. You have just used 1 gig. It's still going on. 2 gig is that one is counting upward. Why the stack is reducing your memory. I just use that for us to